Hi, my name is Soya, and I'd like to introduce our work. This is joint work with Jonathan Bragg, Michael Chang, Kevin Larson, and Danielle Bragg. In this work, we made three contributions. First, we explore challenges for low vision users reading complex documents online. We devised system design for low vision readers. At the end, we compile guidelines on how to design interfaces accessible for low vision readers. I want to start by summarizing how low vision readers read online. So this is a view of the same paper. On the left, this is how much I can see in my screen, basically not magnifying at all, and is enough to fit one paragraph, section title, and a figure. On the right, this is what researchers with low vision might typically see. They normally zoom in a lot that it fits 5 or less lines in their view. And most of the time, they zoom in more than browsers can handle, so lines are not wrapped, so they also need to scroll horizontally. You're in luck if you know where you're reading, but it's easy to get lost with such a small viewport. So orienting themselves and finding information is challenging for researchers with low vision, especially documents complex like research papers. And as researchers read a paper, navigating information happens constantly and humorously. Here are some examples of what and why researchers look for when they read academic papers. The first motivation is because researchers find the passages they're reading particularly interesting. For example, they might be text that referring to particular sections, figures, or tables, and they might look for details of the concept in the paper. Also, another reason is that because the part they're reading, it does not make sense. For example, part like abstract, they're oftentimes information dense, so it might be confusing. So they might want to jump to the parts, the section that explain more in details, so they can clarify what they're reading. Another reason is that because they want to make a comparison. So for example, if there's two figures or study design data sets similar within a paper, they might want to jump between two parts to make a comparison. Lastly, low vision readers or researchers might want to look for more information in the paper because they just simply forgot the meaning of the definitions or terms. So they might want to go back to the part they're talking about definitions or jump to a certain section. Our goal is to build an interface that enables low vision researchers to navigate academic paper easily. So we conduct a Needfinding interview study with low vision researchers. We built 4 prototypes to explore and flag researcher reaction feedback to them. The prototypes were designed through iterative design process to enable fast access of information within an academic paper for researchers with low vision. They are also chosen to encompass a diversity of types of information, as well as a range of presentations. So the first is bridges. So whenever there's a part of the passage that you're interested in, you can click them and the interface will take you to the corresponding part in the paper, and you can go back by click back button to the original part you're reading. The tab is similar to the bridges. When you click the interesting part, you will open the new tab within an interface. So you basically have anchor to the various part in the paper, and you can keep revisiting between the tabs. The collapse is the interface for various information in the paper. So basically academic papers include various classes of information such as system description, study method, experiment, and data. So the collapse interface only shows related text and hide the rest of the text by default. The scrape interface rearranges the order of paragraphs and sections in a paper as user needs. So the user can read information that they are interested in first, regardless of what original paper looks like. So if they want to read more about a certain part of the paper, then they can bring the linked part of the paper into the current text for on demand. So we present this interface to low vision researchers and let them play with it, and we have we observe these findings. So the first is that low vision highly prefers the interface to let them preserve viewport location and make them do less scrolling. Since they had to magnify a lot with such a small viewport, it really takes a long time to find where they're reading. So they want to avoid moving to the part at all. And another reason is they want to preserve author's narrative. Low vision researchers want to keep the original contents as much as possible, even if it might helpful changing the paper might help them, because once they start changing it, they have a fear of missing out of what author originally intended to. From these interfaces, we seek to design our interface for Ocean. Ocean is reading interfaces accessible for low vision users. And based on our reactions and feedback from our users, we decide to keep two features, bridges and tabs. In Ocean interfaces that users privately leave reading the traces, and they use traces to navigate a paper. So this is a demo of the interface. Basically, reader can have this bridges and tabs and see other bridges and tabs created by other people. And this is how you create the bridges. Once you highlight the part, later when you find another end of the bridges, you can connect these two parts, and yourself and your colleagues also can use these bridges. So we deploy our system to a multi-ability team that consists of low vision and sighted researchers. And we have this finding. So regardless of sighted or low vision researchers, they're able to create bridges for personal benefits. So users created bridges and tabs to clarify the parts they're reading, the part they're confusing them to clarify the part. And they're able to adopt different navigation features based on what their needs. Between these bridges and tab, depending on what information they're looking for, they're able to quickly switch between two features. Lastly, our users have this, we made this remark that this type of reading traces allow sharing interpretations. So they mostly compare our features with comments and annotation in the reading systems, which is a prevalent form of the collaborative reading. So they said the reading traces have a unique effect because compared to the comments annotation, which are demanding and they feel like they have to polish more to make annotation, but they feel like the reading traces requires less time and effort, so they're willing to share more so with their teammates. Based on our two studies, we compiled the following guidelines. For the interest of time, I'm going to only talk about one of them, which is about the equal access to original text. So some accessible tools out there propose special tools intended to use only by low vision readers. However, this is highly not preferred by low vision readers because even though they basically understand the tool might benefit, they can benefit from those tools, but they have a fear of having different understanding or different view of the same information as their sighted users. Thanks for listening, and you can find the rest of guidelines from our paper.